Hey guys, this looks like a fun one. It's asking for the area of the blue semicircle. And it looks like it's perfectly inscribed inside of a 3, 4, 5 right triangle. I've already done a video like this where I took a 3, 4, 5 triangle and found the area of the inscribed circle. And this was equal to exactly pi. I wonder what a semicircle inscribed just like this would be. But let's see if we can figure out exactly what the area is. If you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. So first, from this point of tangency, if we drop the perpendicular line to here, we know that this line is going to go through the center of the circle. And the center of the circle is going to have to lie on this diameter. So this right here is the center. I can try to explain that better. Every radius of a circle is at right angles to the tangent lines. And the converse is true as well. Every single line drawn at right angles to a tangent line at that tangent point will always pass through the center of the circle. And let's label this radius with r. Next, we can draw this perpendicular line to this tangent line at this tangent point, and that will also be a radius, so we can call this r. And now we have a quadrilateral with 3 right angles. This has to be a square, which means this side of the square is equal to r, and this side of the square is equal to r. Next, let's look at this height of our triangle. It's equal to 3. Since this piece is equal to r, that means this portion up here would be equal to 3 minus r. And the same thing if we look at the base, since the whole thing is equal to 4, this is equal to r, this portion would be equal to 4 minus r. And next, let's focus on these two parallel lines and this transversal. If we mark this angle theta 1, this angle would also be equal to theta 1. These are called corresponding angles. As long as these two are parallel, the corresponding angles will be congruent. And we can do the same thing here and look at these two parallel lines. If we label this angle theta 2, this angle would also be theta 2. And these are also corresponding angles with two parallel lines. So now let's bring everything back and let's look right here. Since this is a right angle and this is a straight line, this will also be a right angle. And same thing down here, since this is a right angle, this will also be a right angle. And now we can focus on these two triangles. Since these two triangles are made up of the same 3 angles, they are similar to each other. So we can set up a proportion looking at their side lengths. We can do the height of this triangle 3 minus r over the height of this triangle r is equal to the base of this triangle r divided by the base of this triangle 4 minus r. And now we can use this proportion to solve for r. First, we're going to cross multiply. R times r is equal to r squared. And on the right-hand side, when we multiply these, we get 3 minus r times 4 minus r. Next, we're going to have to multiply out this right-hand side. That'll give us 12 minus 3r minus 4r plus r squared. And that'll simplify to 12 minus 7r plus r squared. So from here, let's move all the r's to the left-hand side. So we can add 7r to both sides, and we can subtract r squared from both sides. On the left-hand side, the r squared minus r squared will go away, so we're left with 7r. And on the right-hand side, all of this stuff will go away, so we're just left with 12. From here, we can divide both sides by 7, and we get r is equal to 12 sevenths. This r stands for the radius of our semicircle, so we're pretty much done. The area of a semicircle is equal to 1/2 pi r squared, and in the place of the r, we're going to plug in 12 sevenths. When we do a fraction squared, the squared goes to both the top and the bottom, so we'll have 12 squared over 7 squared. 12 squared is equal to 144, and 7 squared is equal to 49. And then we can simplify this a little bit further. This 1/2 can multiply by the 144 to give us 72. And now we have the answer to the question. The area of the blue semicircle is 72 over 49 pi units squared. Let's put a box around it. How exciting.